these U and V are energy U of R, P, and this and V are of P. These are positive and negative energy spinors, and they are constant spinors. Okay, and so U bar would be U dagger gamma 0 and so on, and they would obey the Dirac equations P slash minus MC URP equal to 0 and P slash plus MC VRP equal to 0, where P slash is gamma mu P mu. P slash is gamma mu P mu, and here U R dagger U R equal to VR dagger VR equal to EP by MC square, and these are the norms of these spinors, and U R dagger US is VR dagger VS. These are the orthonormality property. EP by MC square times delta RS, so they contain the norm as well as the orthonormality properties. And actually, so, and of course, U dagger of P Vs of minus P, this would be 0. And then you see, you can construct for this particular theory, you can construct all those things, the constants of motion that I said, the 4 components of T0 beta, which means energy, T00 energy, and field momentum, 3 components of field momentum. So you can calculate them. You can calculate the charge operator here. There is a very long story for the charge operator of this theory. It would be some constant times dqf etc. times nc minus nd, the number operator for the C type of particles and D type of particles, or for the electrons and positrons. And what happens when you calculate H in this, then you do not get a positive definite energy for the theory unless you impose these anti-commutation relations for the Dirac theory. So this was a measure of research, very active research by the then leading physicists half a century ago, that they were having troubles in getting positive definite energy for the Dirac spinor field theory, because it was always coming out to be non-positive definite, and this was because they were still assuming the commutation relations for the annihilation and phase operators. They were used to that. And then it was discovered, no, this theory is describing fermions with spin 1/2 up and down, and this is different than the bosons. There has to be, so this was, you should read sometimes the details of these stories. They are very interesting stories, that these guys, how they arrived at the consensus that, okay, so we finally agree, we surrender that if you want to get positive definite energy for the Dirac field energy in the Dirac theory, you have to impose anti-commutation relations. So you see, when now we will slowly go into the details of this and into the details of this, and whatever we have done, we will recap our important concepts, and you will see that here the Fourier modes, they would obey the commutation relations, and here they would obey the anti-commutation relations, and not only that, they would obey the complete Dirac algebra of these anti-commuting or fermionic oscillators, let us say. So, because the oscillators that are involved in the Dirac theory, they are fermionic oscillators. And this is exactly that thing. We are adding it to our bosonic piece of the action, and fortunately to our rescue we have supersymmetry transformations that transform our bosonic fields into fermionic and fermionic into the bosonic, and so it's perfectly fine for us, and therefore we can describe bosons and fermions both in our same theory. And you will see, actually, when we generate the mass spectrum of this theory, then you will see how you generate bosons and fermions out of the same theory in different manner. I cannot describe it in words right now. I will have to write down mathematics stuff on the mathematics to be able to show you that. And with that, I think we can stop for the day. So let me thank you all very, 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 very much. Okay.